Hello, my name is Desmond Edagisi, and I'll be taking us on the subject geography. We'll be looking at the theme, the Earth and the solar system. And our topic for today is the Earth and other planets. Let's go into our class. At the end of our class today, I expect that we must have learned all about the solar system. We'll also learn about our planet Earth. The Earth, our home, is but a little part of an enormous universe. The universe is an exciting place, full of countless number of stars, and each of these stars are beautiful and unique in its own way. These stars are arranged in space in clusters or groups known as galaxies or nebulas. Some galaxies are round in shape, some are irregularly shaped, and some are spirally shaped. The galaxy in which our Earth is found is known as the Milky Way galaxy. This is a picture of what the Milky Way galaxy looks like. It has 5 arms, and our planet Earth, which belongs to a system called the solar system, can be found somewhere around here. The solar system, as its name implies, is a system focused on the sun. Solar means relating to the sun. Let's go on to know more about the solar system. The solar system consists of the sun and every other thing that is bound to it by gravity. One of the things bound to it by gravity are the 8 planets. It also contains moons. For example, the Earth has just 1 moon, whereas Jupiter has close to 70 moons. It also consists of asteroids. Asteroids are bodies that are either rocky in nature or metals that also revolve around the sun. It also consists of comets, which are planetary bodies made of ice and dirt. When it gets close to the sun, some of the icy particles burn off, leaving a brilliant trail of light. Also, in the solar system, we have dust, planetary dust, and gases. The sun, we have said, is the center of the solar system. It is a star, a very hot spinning ball of glowing gas. Gases within the sun, hydrogen and helium, burn and react, giving off heat and light energy. The light energy given off by the sun gets to the Earth in about 8.5 minutes. The sun is made up of 70% hydrogen, 27% helium, and other elements. It has a surface temperature of 6,000 degrees centigrade. That's very hot. But within its interior, it has temperature that ranges up to 20 million degrees centigrade. The sun gives heat to our planet Earth. In comparing the size of the sun to the Earth, by ratio, the sun is 300 times larger than our planet Earth. In volume, if we were to fit the Earth into the sun, we would have close to 1 million Earths fitted into our sun. That tells us how very large the sun is. The sun contains around 98% of all the material mass in the solar system. Due to the size and density of the sun, it has very powerful gravity that attracts all other objects in the solar system towards it. So we have our sun, and we have our planetary bodies. This is an example of a comet that we talked about earlier. We have planets, and we have an asteroid field. Each of our planets, the comet, the asteroid field, and floating gases round space all revolve round our sun because of the gravity that pulls each of these objects towards it. And this is as a result of the massive size of our sun. So everything in the solar system directly or indirectly revolves round the sun in elliptical orbits. These lines represent the orbits. They're elliptical in shape, hence the name elliptical orbits. The moons of our planet, for example, Earth, revolves round the Earth, while the Earth revolves round the sun. So we can say the moon indirectly revolves round the sun. The moons also of other planets, Jupiter, for instance, that has close to 70 moons, all revolve round Jupiter, while at the same time Jupiter revolves round our sun in elliptical orbits. So again, the moons of Jupiter are indirectly revolving round the sun. So everything within the solar system, in one way or the other, both directly and indirectly, revolve round the sun. An elliptical orbit is a path taken by the planetary body round the sun, which is the center of the solar system. Over the years, as the body journeys round the sun, the distance to the sun varies. There are times when the distance is much longer and at times when it is shorter. The shorter distance in the variation is what we refer to as aphelion, while the perihelion, which is the opposite of the aphelion, is the distance towards our sun that is much shorter than the longer part. From its origin, perihelion means close to the sun. The planets that orbit the sun are divided into the inner planet and the outer planet. The inner planets are 4 in number, and they are referred to as the terrestrial planets. They are called terrestrial because they are primarily composed of rock and metal. These planets are Mercury, Venus, the Earth, and Mars. There are 4 outer planets also, which are referred to as Jovian planets, being substantially more massive than the terrestrial planets. Let's learn more about the outer planets. The outer planets are Jupiter, Saturn, Uranus, and Neptune. The 2 largest of our outer planets are Jupiter and Saturn. These are the gas giants, being composed primarily of hydrogen and helium. The 2 outermost planets, Uranus and Neptune, are referred to as ice giants because they are composed mostly of substances with relatively high melting points called ices, such as water, ammonia, and methane. We're going to look now at our 8 planets, taking each one according to their distances from the sun. The first planet we'll look at is what? Mercury. Mercury is the closest planet to the sun and also the smallest. It is only 57,900,000 kilometers, that is 36 million miles away from the sun. Because of its proximity to the sun, it completes its orbit round the sun in a much shorter time than the Earth and other planets. So a year in Mercury is only 88 days on Earth. Temperatures in Mercury, because of its proximity to the sun, can go up to 500 degrees centigrade when it faces the sun, and away from the sun, it can go as low as 150 degrees centigrade on its dark side. The next planet in proximity to the sun is Venus. Venus is a planet that is popular because of its brightness. It is known as the morning and night star because it is visible with the human eye on a very dark night and in the early morning. It is also named after the Roman god of beauty. It is known as the Earth's twin because of its similarity in size with our planet Earth. They have similar size, mass, and density. It is the hottest planet in our solar system. Temperatures in Venus can go far above 500 degrees Celsius, which is very, very hot. The Earth is the third planet in our solar system. It is also the largest planet amongst the 4 inner planets and the 5th largest of all the 8 planets. Earth has a natural satellite that rotates around it, which is the moon. A satellite is any planetary body that rotates around a planetary body that in turn rotates around the sun. So the moon is a satellite that rotates around the Earth. It is the only planet that has life in it. Earth has suitable atmosphere and condition that can support life. So on Earth, we have vegetation, we have humans, and we have animals of all kinds that are supported by the conditions conducive on Earth. Life on Earth exists because there is oxygen in our atmosphere. The Earth, which is also referred to as the blue marble, is made up of 75% of water. So from space, the Earth looks very blue because of the abundance of water within it. Mars is the 4th planet in the solar system. It is referred to as the red planet. It gets its color from a compound, iron oxide, that is abundant on its surface. Iron oxide is a red compound and very much abundant on the surface of Mars. Mars has 2 satellites or moons. We've learned what a satellite is. So Mars has 2 of them called Phobos and Deimos. The Martian atmosphere is made mostly of carbon dioxide with small amounts of nitrogen, oxygen, and water. Mars has temperature that ranges from 17 degrees centigrade to minus 125 degrees centigrade. Jupiter is the 5th planet in our solar system, and it is the largest planet in the solar system. It has 1,400 times the volume of Earth, but it is only 300 times as heavy since it is made up of gas rather than rocks or metals. Jupiter has over 60 moons, that is over 60 satellites. 4 of them are quite large and known as Io, Europa, Ganymede, and Callisto. There are other smaller moons that also revolve round Jupiter. It takes Jupiter almost 12 years to orbit the sun, but it completely rotates around its axis in only every 10 hours. Our planet Jupiter, again, if we remember, is the largest planet in the solar system. Let's go on. Saturn is the 6th planet from the sun. Saturn is also the 2nd largest planet in our solar system. It is very uniquely shaped and quite different from other planets in the solar system. If you notice, the shape of Saturn has rings around them. These rings are made of icy rock and frozen gases. Light from the sun that reflects on the rings makes them shine very bright. A typical Saturnian day lasts about 10 hours, while it orbits the sun once every 30 years. Uranus Uranus is the 7th planet in our solar system. Uranus orbits the Sun in 84 years and takes 17 hours to rotate about its axis. Uranus is also a very unique planet in that it is the only planet that has its axis tilted in a sideways manner, which makes its poles to point directly at the Sun, and thereby it orbits the Sun on its side. Uranus belongs to the gas giants. Its atmosphere consists mostly of hydrogen and helium, and a little bit of methane. Neptune is the 8th planet in the solar system. It does not shine so brightly, so it is only visible when you use a telescope. Neptune is a ball of gas, and like its brother planet Uranus, it is blue in color. This color is gotten from frozen methane, which makes up the atmosphere of Neptune. It is almost 4.5 billion kilometers away from the Earth, and it takes close to 165 years to travel around the Sun once. Neptune's day is shorter than the Earth's day, only by 16 hours. Pluto was originally considered as the 9th planet in the solar system, but because it's not a dominant body in its orbital vicinity, Pluto, since 2006, has been reclassified by the IAU, that is the International Astronomical Union, to be a dwarf or a minor planet. Now, let's learn about the Earth, the planet in which you and I live in. The Earth, like we've learned, is the 3rd planet from the Sun. The Earth has just one satellite, the Moon. As you can see, this is our Earth, and here is the Moon. The Moon, as a satellite, revolves around our Earth. The Earth's axis of rotation is tilted at about 23.30 degrees in relation to the ecliptic plane. The ecliptic plane is an imaginary surface through the Earth's orbit around the Sun. So we have our ecliptic plane, which is our plane here, and we have our Earth tilted to 23.30 degrees. Our equator is turned in this direction, and we have our poles. The North Pole at this position, and the South Pole. It takes approximately 24 hours for the Earth to completely rotate about its axis. So the Earth rotates about its axis in 24 hours. The Earth also completes one orbital journey around the Sun every 365 days. So the Earth, like we've learned, is one of the planets that revolves around the Sun. And it takes 365 days to totally orbit or go around the Sun completely one time. The Earth is the 5th largest of all our 8 planets in the solar system, and it is the largest of the terrestrial planets. It is smaller than our 4 gas giants, Jupiter, Saturn, Uranus, and Neptune, but larger than the other 3 rocky planets, which are Mercury, Mars, and Venus. In comparison, we see our planet Earth, like we mentioned earlier, is similar in size to Venus, also similar in density. Mars, of course, is much smaller than the Earth, and Mercury is the smallest of all the planets in the solar system. The mass of our Earth is 6.6 septillion tons. That is, in kilograms, it is 5.9722 times 10 to the power 24 kilograms. That's quite massive. Its volume is 1.08321 times 10 raised to the power 12 cubic kilometers. The Earth is the densest of the terrestrial planets because of its makeup. It is made up of a crust which contains the dry land and the ocean floor. The crust is the visible part of the Earth, but beneath the Earth, directly beneath the crust, we have the mantle, which is a rocky part of the Earth. The mantle also contains semi-solid minerals and rocks. We also have the core, which is divided into the inner and outer core. The core is a ball of metal, mostly iron and nickel. This core gives the Earth its very dense nature. The density of the Earth is 5.52 grams per cubic centimeter. The total surface area of the Earth is about 197 million square miles. In kilometers, that would be 509 million square kilometers. About 71% of the Earth is covered by water. So the Earth is mostly made up of water, while 29% contains the land that you and I can walk upon. The mean radius of the Earth is 3,959 miles. In kilometers, that would be 6,371 kilometers. The Earth is round because gravity pulls matter into a ball. Although it is not perfectly round, the Earth is said to be oblate spheroid or ellipsoid. The roundness of the Earth is squashed in or flattened at its poles. So these are our poles. And if we notice this shape, which is a true representation of what the Earth looks like, the poles are squashed in, while the sides or the equator here acquire a bulge. This shape is what is referred to as an oblate spheroid. Oblate refers to an oblong shape. So the Earth, as we can see, is slightly oblong. And spheroid indicates that the Earth is also slightly spherical in shape. This shape effect is caused by the spin or the rotation of the Earth, coupled with gravity acting on the Earth. The Earth's equatorial diameter is 7,926 miles. In kilometers, that's 12,756 kilometers. That is the measurement from one end of our equator to the other. The equator is the bulging part of our Earth, like we just saw earlier. That measurement gives us 12,756 kilometers. The measurement, however, from our North Pole to the South Pole, that is the polar diameter, gives us 12,714. So we see the difference. In the equator, we have 12,756, while along our polar regions, we have 12,714. We have a difference of 42 kilometers. This proves again that the Earth is not totally round, but it's oblate spheroid. It is more spherical than round. The circumference of the Earth also at the equator is 24,902 miles, but from our north to south pole, that is the meridional circumference, we have 24,860. So again, we see a difference in the measurements to prove again that the Earth is slightly spherical than round. Before now, there have been arguments as to the veracity of the claim that the Earth is spherical in shape. Others have argued that the Earth is actually flat. We're going to look at some points that prove that the Earth is not flat, but more spherical in shape. One of the first proofs was gotten many years ago, 1519 to be exact. A seafarer known as Ferdinand Magellan and his crew sailed from the ports of Spain and sailed west, going through the Atlantic Ocean, through the Straits of Magellan, through the Indian Ocean, and arrived again back at their point of departure. This journey long ago proved way back then that the earth was certainly round. If it was flat, this journey would have taken the seafarers way off the edge of the earth, and they would have fallen off the edge of the earth. So again, the circumnavigation of the earth by Ferdinand Magellan and his crew proved that the earth was spherical. Another evidence as to the sphericity of the earth is noticed when we stand on the deck of any ship. Do an exercise if you can. Take a look at the distant horizons from the deck. This is the kind of picture you would see. A circular horizon. If the earth were indeed flat, what you will be seeing is not this circular horizon, but a flat view from whence you could even see the shoreline far, far away. So again, this proves again that the earth is spherical and not flat. Another very good evidence as to the sphericity of the earth is the phenomenon of the lunar eclipse. The lunar eclipse has to do with the eclipse of the moon. A lunar eclipse occurs when the earth comes between the sun and the moon. When this happens, a shadow from the earth is cast on the surface of the moon, depending on the location of the moon, behind the earth. So if it is directly behind the earth, aligned along with the other planetary bodies in a straight line, would have a total eclipse of the moon. If our moon, which is rotating around the earth, moves into this region, it becomes a partial eclipse. And the shadow that the earth casts upon the moon would look exactly like something like this. Now, the shadow, if it is studied, we would notice that the shadow is circular in shape. This proves that the earth that produced the shadow must be a round object. No flat object can produce a round shadow. So once again, this proves that the earth is spherical and not flat. Another way we can prove the sphericity of the earth is to look at the sunrise and the sunset. The sun rises and sets at different times in different places. If the earth were indeed flat, the whole world would have sunrise and sunset at the same time. That is a proof, again, that the earth is indeed round and not flat. Another good evidence of the earth's sphericity is the observation of planetary bodies making use of our telescopes. Now we have telescopes that are powerful enough to see the outline or the shapes of planetary bodies from our planet Earth here. Every planetary body so far studied have been found to be round in shape. So we studied planetary bodies like Neptune, Uranus, Saturn, Jupiter, Mars, Earth, Venus, even the Moon, and Mercury. All the planets so far studied, and even more planets that are being discovered every day, are all round in shape. And of course, we would not expect Earth to be any bit different. So indeed, we can say that Earth, just like the other planetary bodies, is also round and not flat. And finally, another very good way to prove that the Earth is spherical and not flat are photographs that we've gotten from various space explorations, explorations from the moon, explorations from orbital satellites that go around our Earth, and all manner of explorations we've had over the years. Different photographs have come back to show exactly what the Earth looks like from outer space. So from the moon, this is a picture that was taken of the Earth. And from satellites orbiting our Earth, these were also photographs that were taken, all showing that the Earth is truly spherical and not flat. In summary today, we've learned about the solar system. We said that the solar system consists of the sun and every planet that orbits the sun. That is, every planet that goes round the sun. Aside from planets, we said the solar system also consists of moons, comets, asteroids, and dust and gas that also orbit the sun. We learned also that the 8 planets of the solar system are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. We broke down these planets into the inner planets, also called the terrestrial planets, and the outer planets, which are the gas giants. We said the inner planets are Mercury, Venus, Earth, and Mars, while the outer planets are Jupiter, Saturn, Uranus, and Neptune. We learned that the Earth is the 3rd planet from the Sun. We also learned that it's the 5th largest of the planets in the solar system and the largest in the terrestrial planets. We learned also that the Earth is not typically round, but it's an oblate spheroid shape. To see how far we've learned today, let's take some quick questions. The planetary bodies of the solar system revolve around the option A, Venus, option B, Sun, option C, Neptune. What would be the correct answer? Did you say Venus? Then you were wrong. Neptune is also wrong. The correct option is option B, the Sun. The planetary bodies of the solar system revolve around the Sun. Remember, we said even the word solar means relating to the Sun. So next time you hear the word solar, of course you know we're talking about the Sun. Let's take our next question. Which of these is the largest planet in the solar system? A says Earth, option B, Jupiter, and option C, Mars. What do you think is the correct answer? Option A, Earth, is definitely wrong. Option C, Mars, is also wrong. And our option B is our correct answer. So Jupiter, which is the 5th planet, is also the largest of all the planets in the solar system. Let's try this other question. The shape of the Earth is option A, perfectly round, option B, perfectly spherical, and option C, oblate spheroid. The correct answer is oblate spheroid. The Earth is not round as many people imagine. Neither is it perfectly spherical, but slightly spherical and a little bit elongated at the equators. That is an oblong shape, hence the name oblate spheroid. Let's take our last question. The Earth's axis of rotation is tilted to about option A, 23.30 degrees, option B, 37.5 degrees, and option C, 15.8 degrees. The correct answer is 23.30 degrees. With that, we've come to the end of our class for today. I certainly hope you had a nice time learning about the Earth and its planets. I look forward to taking you in our next class, which promises to be very exciting. Till then, my name again is Desmond Edagese. Bye for now.